Today we're going to do our second lesson on inverse functions. So we're going to start off by graphing x squared plus 3. So our parent function here is the quadratic parent function. So looking at our catalog, we know that it is 0, 0, 1, 1, 2, 4, 3, 9, negative 1, 1, negative 2, 4, negative 3, 9. So this is our parent function for quadratic. This plus 3 is outside the squared, so this means you're moving up 3. So all my points are shifted up 3. And this one goes off the graph. I'm going to connect my points. So this is f of x. Is f of x 1 to 1? Does it pass the horizontal and the vertical line test? So it passes the vertical line test, but it doesn't pass a horizontal one. So this one's not 1 to 1. If it's not 1 to 1, this means that it's not going to have an inverse that is a function. So what we need to do is to restrict the domain so that it is 1 to 1. So what we're doing here is we're going to get rid of half of our function so that it's going to pass the horizontal line test. So the part we're going to get rid of is the left side. So we're only going to look at the right side of this function, because now if I draw a horizontal line, it'll pass the horizontal line test, which means it is 1 to 1. So the part that I'm looking at for my domain, I'm only going to look at when x is greater than or equal to 0. So I'm only looking at the right side of this. So if I only look at this side, my function is still x squared plus 3. But now my domain, if I'm looking only on the right side, goes from 0 to infinity. And my range, my lowest point starts at 3 and keeps on going up, so also to infinity. So if this is my domain, then for my inverse, I know that my domain is going to be the range. So these two are going to switch places. And I'm going to use a different color to graph my inverse. So for my inverse, 3 comma 0 becomes, or 0 comma 3 becomes 3 comma 0. 1 4 becomes 4 1. 2 7 becomes 7 2. I'm going to connect them, and this is my inverse f negative 1. So our domain does match up with that. And to find my equation, same thing we did yesterday. So we have y equals x squared plus 3. Our first step is to change our x and our y. So this is x equals y squared plus 3. And we're going to solve for y. So minus 3. X minus 3 equals y squared. To get rid of the squared, we take the square root. And that leaves us with y equals the square root of x minus 3. So that is my inverse function. So what we learned here is if you ever have a function that's not 1 to 1, what we have to do is restrict the domain, which means we're really just canceling out half of our graph so that it is 1 to 1, and then do our inverse function from there. So let's take a look at another example. So for number 2, let's graph this. So these two lines right here means that this is an absolute value parent function. So absolute value, our parent function is 0, 0, 1, 1, 2, 2, 3, 3. In both directions, it's the v. There's two things that are happening here. This 2 on the outside means we're multiplying all of our y's by 2. So it's a vertical stretch. The minus 4 means we're moving right 4. So which one do we do first? Our stretch. So we're stretching everything by 2. So before this was your y value is 3, now it's going to be up here at 6. If before this was at 2, this is now at 4. 1 is now at 2. 0 still stays there. 2, 4, and 6. So we're stretching everything vertically. And now we're just going to move all of our points to the right 4. So 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. This is my function. So as you can tell, this is currently not one-to-one because it doesn't pass your horizontal line test. And so what we need to do is, restrict the domain. So again, we're going to just cross off this side of it. And so we're only looking at this right here. So our domain here is if we're starting at 4 and it's going to the right, my domain is going to be 4 to infinity. My range, look, lowest point to highest point, is 0 to infinity. And now we're going to do everything else the same. We're going to find our inverse. So I'm going to use a different color. We're going to start with this point. 4 comma 0 becomes 0, 4, which is right here. 5, 2 becomes 2, 5. 6, 4 becomes 4, 6. And 7, 6 becomes 6, 7. So this is my inverse. And as you can tell, it's been flipped across my y equals x line. So my domain here, so these two are switching, so now it's going from 0 to infinity on my x's, and my y's are going from 4 to infinity. And now we're going to solve for my inverse function. So we're starting off with our original function, we're switching our x and our y. So what is important about this one, because we are only looking at a domain of 4 to infinity, so we're only looking at when this function is greater than 4, this absolute value sign actually doesn't matter anymore, because if it's bigger than 4, then this is always going to be positive. So we're just going to pretend like that's not even there. We're just going to say that it's parentheses. Okay, so first thing I'm going to do is get rid of this 2 by dividing by 2. So this is x over 2 equals y minus 4. And now get rid of the 4 by adding. So we have y is equal to x over 2 plus 4. And now my y is by itself. So this is my inverse function. Okay, let's do one more example now with rational functions. Flip the page. Okay, so for my rational function, I'm first going to plot this original graph. So I'm going to start off by factoring. This is really 1 over x squared minus 4, x minus 2x plus 2, difference of squares. So let's start off finding our vertical asymptote. Vertical asymptote is denominator doesn't equal 0, so denominator can't be equal to 2 or negative 2. So here are my vertical asymptotes. For your horizontal asymptote, we're going to divide. When you divide 1 divided by x squared minus 4, can you do 1 divided by x squared? No, you can't. It's impossible. So your horizontal asymptote is y equals 0, because it can't go into that number. So we have a horizontal asymptote right on the x-axis. Okay, for our x-intercept, numerator equals 0. We set the numerator 1 equals 0. Is that possible? Nope. So none. 1 is never going to be equal to 0. For a y-intercept, we're going to plug in 1 over 0 minus 4, so this becomes negative 1/4. And negative 1/4 is going to be my y-intercept, so 0, negative 1/4. So let me plot negative 1/4, it's about right here. So using this, I can now draw the rest of my graph. So I know this is going to go towards my asymptotes in both directions. On this side, if I plug in a number greater than 2, so let's say 3, 3 squared gives me 9, 9 minus 4, this is going to be positive, so this is on this side. Over here, negative 3 will still give me a positive 9 minus 4. This is also going to be positive, so this is my function. So looking at this function, this also does not pass the horizontal line test, right? If you draw a horizontal line, it touches it at more than 1 point. So this is not 1-to-1. So again, we're going to have to restrict our domain. So what we want to do here is again get rid of this half. So we're only going to be looking at this half of the problem. So if we're looking at this half of the problem, we're completely ignoring this negative 2. We're getting rid of that one. So let's look at our domain now. So our domain, we're only looking from 0 to infinity. But we know our x also cannot be equal to 2 because that's our asymptote. For our range, let's go up and down. So let's start at the lowest point. We know it's going to start at negative infinity. It's going to go all the way up to this point right here, which we know is our y-intercept. It's negative 1/4. Because it's a point, this is going to be a bracket. Then it's going to start at this asymptote, which is at 0. Because it's an asymptote, it's a parentheses, and it keeps on going up forever. That's my range. Okay, for my inverse, I already know these are just going to switch places. So negative infinity to negative 1/4, 0 to infinity. Range is going to go from 0 to infinity, and now this is y doesn't equal 2, but those are the same. For my inverse, now my vertical asymptote and my horizontal asymptote are going to switch. So before, this was 2 and 0. Now my vertical asymptote is going to be 0, and my horizontal asymptote is going to be 2. And my x and y-intercept also switch, so my x-intercept is now going to be negative 1/4, comma 0, and my y-intercept is going to be none, because that's what my x-intercept used to be. So negative 1/4, 0 is going to be right here. And we know that this is going to go towards the asymptote over here. And what's happening from this graph to this graph is that it's being flipped. So it makes sense that this graph is ending up going this way. When you flip this, it's still going to end up being above the line like this. So this is my graph. Now we just have one last thing to do, which is, again, find our equation. So we're starting with our equation. We switch our x and our y's. To solve for y, I'm going to have to get rid of the fraction, so I'm going to multiply by the denominator on both sides. This leaves me, distribute, xy squared minus 4 equals 1, minus 4x. And you want to get all the y's on one side, all the x's on, or everything else on the other side. So this is the y we're trying to get by itself. So I'm going to add 4x to bring it over here. I have xy squared equals 4x plus 1. And to get x by itself, or y by itself, now I'm going to divide by x to get rid of this. I have y squared equals 4x plus 1 over x. Last step, get rid of that squared. We're going to square root. And that gives us y by itself. And it's square root of 4x plus 1 over x. So that's what goes up here. 4x plus 1 over x. That is my inverse function.